When you walk into a building, what gives you the confidence that the building won't fall? Is it the fancy walls or art, or is it the foundation? Every magnificent structure begins with a foundation you rarely see. Months before a building reaches for the sky, engineers are digging deep, laying concrete and creating a solid base that will determine how high and how safe that building will eventually become. For digital tech products, that hidden foundation is the tech stack. Just like a physical architecture, your product's digital foundation determines not just what you can build today, but what you can build tomorrow. But what exactly is a tech stack? Imagine a layered cake of technology. At the bottom, you have your infrastructure, which can be physical servers or cloud services like AWS or Google Cloud. On top of that, you have your operating systems and databases that store and organize your data. Next comes your technologies in the form of programming languages and frameworks that process information and business logic. And finally, your front-end technologies that enable users to interact and actually see your product. Together, these layers form what is called a tech stack, which is simply a collection of programming languages and frameworks, and also tools and platforms that power your digital products. It's the invisible architecture that determines how fast you can build and how easily you can change direction, and ultimately how high your business can climb. Today, I want to tell a story of how decisions on tech stack have a profound impact on a product years after its initial build. So the story goes, in 2006, a small team led by Jack Dorsey launched Twitter. Speed to market was critical, so they built their platform on Ruby on Rails, which is a framework that allowed them to move fast and launch quickly. Ruby on Rails was perfect for what Twitter needed then: rapid development, simple features, and a small user base. The technical term for this is minimum viable product. The team could implement new features quickly, experiment freely, and get their product into users' hands without months of development. But what happens when your startup succeeds beyond expectation? From 2007 to 2009, Twitter's user base exploded from thousands to millions. Suddenly, their database had to manage billions of relationships rather than millions. And that's when users began seeing a lot of what has come to be known as the fail whale, which was Twitter's cute but frustrating error message that appeared whenever the servers crashed. During major events like the 2008 election or the 2010 World Cup, the platform became virtually unusable. The story reaches a turning point when Twitter realized that their initial tech choice, while perfect for launching, wasn't built to handle their unexpected success. Ruby on Rails, which had enabled their rapid growth, was now becoming a limitation. Twitter faced a pivotal decision that would shape their future. The first option was to continue scaling on their Ruby on Rails infrastructure with increasingly complex workarounds. The other option was to rebuild their tech platform from scratch with better technologies that would be better suited for the workloads. None of the choices was pain-free. They chose a third path, which was a hybrid approach. Rather than starting from scratch, Twitter began a year-long process of re-engineering their platform piece by piece. They identified the most critical bottlenecks and gradually replaced them with more scalable technologies, moving key components from Ruby to Java and Scala, which could better handle their massive user base. They rewrote their message queue system to handle higher volumes. They rebuilt the search functionality for better performance. They replaced their timeline service to deliver tweets faster. Each change improved stability but came at a cost. The best way to imagine this would be to think of having to rebuild foundations on an existing building and having to ensure that the building doesn't collapse as you work on rebuilding the foundations. The Twitter story teaches us something profound. Your tech stack isn't just a technical decision, it's a business decision with long-term consequences. Their early choice to prioritize speed to market made perfect sense for a startup. Build fast, learn fast, adapt fast, but they underestimated how quickly they needed to scale and how costly it would be to change course mid-flight. Twitter's experience isn't unusual. Countless companies face this crisis when your product takes off faster than your infrastructure can handle. The difference between surviving this crisis and being crushed by it often comes down to how well you anticipated future needs in your initial tech stack decisions. This is why it is important to ask your technical team key questions regarding their choice in tech stack. But a tech stack isn't just code and service, it's people, it's community, it's support. When you choose a technology, you're also choosing who you can hire, what problems have already been solved, and who will help you when things go wrong. Consider this. There are tens of thousands of JavaScript developers in South Africa alone, compared to roughly a few thousand developers familiar with less common languages like Elixir. Your hiring pool can be 20 times larger depending on your tech stack choices. When you choose React over Angular, Python over Go, or AWS over Azure, you're not just choosing technology, you're choosing an ecosystem. How many developers know this technology? How active is the community? How many libraries and tools exist to solve common problems? Will you find answers when things break at 2 a.m.? For instance, a JavaScript question on Stack Overflow typically receives an answer within 11 minutes. A question about a more niche technology might wait hours or days. When production is down and customers are angry, that difference matters tremendously. Even worse, if the technology is really novel, not even ChatGPT can help you if the problem has not been solved before. This brings us to another important decision you need to consider: open source versus closed source. Open source technologies like Linux, Python, and React offer transparency, community support, and freedom from vendor lock-in. With open source, thousands of developers worldwide contribute to improvements, fix bugs, create extensions. Problems get solved faster because more eyes are looking for solutions. You can inspect the code directly when issues arise, rather than waiting for a vendor to acknowledge a problem. The open source movement has transformed software development. Linux powers 96% of the world's top 1 million servers. WordPress runs 40% of all websites. These technologies succeed because they benefit from collective intelligence and shared resources. On the other hand, closed source or proprietary solutions from companies like Microsoft, Amazon, Oracle, or Salesforce offer different benefits. They offer official support contracts, service level agreements, and sometimes better integration between products from the same vendor. When critical systems fail, having a phone number to call with a guaranteed response time provides peace of mind, especially for larger organizations. Proprietary solutions often come with professional services, training programs, and established best practices. The right answer depends on your specific needs. If you're handling sensitive financial data with regulatory requirements, a commercial solution with guaranteed support and compliance features might be worth the cost. If you're building something innovative that needs to evolve quickly, open source might give you more flexibility and community-driven innovation. Many successful companies actually blend these approaches, using open source for some components and proprietary solutions for others. The key is understanding which parts of your stack are truly differentiating for your business and which are commodity functions where established solutions make more sense. But there's another factor at play in tech stack decisions, a very human one that organizations often underestimate. Technologies often fall prey to what's called shiny object syndrome, the attraction to new technologies that promise revolutionary benefits but may not align with business needs. History is littered with technologies that were once considered the future but faded into obscurity. Companies that bet everything on these trendy technologies often find themselves with unmaintainable code bases when developers moved on to the next big thing. This is where business and technical leadership must find balance between innovation and practicality, between excitement and stability.
Nah, I've seen everything.
Damn straight. This dude is righteous.
The most successful companies neither chase every trend nor cling too long to outdated technologies. The most successful companies make stack decisions that align with their unique challenges and goals. Let's look at how different businesses have navigated these choices. Airbnb embraced React for their front end because they needed a consistent user experience across multiple platforms. Their business depends on making complex booking processes feel simple and trustworthy. They invested heavily in a design system and component library that maintains consistency while enabling rapid development. Behind the scenes, they use Ruby on Rails, the same framework that Twitter struggled with. But their usage patterns and scale are different. For Airbnb, the benefit of rapid feature development outweighs the performance limitations. They've architected their system to offload intensive operations to specialized services. Your tech stack should grow with you, not hold you back. Many successful startups begin with simple monolithic architectures using established frameworks, then gradually migrate to more specialized technologies as their needs evolve. The right tech stack feels invisible because it simply enables your business to succeed. The most effective approach often involves choosing proven technologies at launch when reliability is critical. As the business grows, selectively upgrading components that limit growth becomes necessary. Resisting the temptation to rewrite everything whenever a new framework becomes popular is key. Instead, the question should be, what problem are we solving? How does this technology choice support our business objectives? So how do you choose? Start with your business needs, not the technology. Ask, what are we building? How quickly must we scale? What talent can we access? What's our tolerance for risk? What's our competitive advantage? Define your non-negotiables. Is performance critical to your user experience? Does your solution need to work offline or in low bandwidth environments? Consider that the decision of a particular tech stack is always a trade-off that is aligned with the overall business strategy. Balance innovation with pragmatism. New isn't always better. Familiarity isn't always limiting. The best technology for a given problem is often the one your team already knows. Involve diverse perspectives in the decision, not just technical voices, but product, business, and operations too. Someone needs to ask the hard questions. How will this choice affect our hiring, our timeline, our ability to pivot if the market conditions change? Plan for evolution. The perfect stack today might need changes tomorrow. Build with components you can replace rather than rewriting everything. Create clean interfaces between systems that allow for future flexibility. Remember that the fastest to market isn't always the fastest to scale. Sometimes investing more upfront in architectural decisions saves exponentially more time and money later. Other times, moving quickly is exactly the right choice when future requirements are uncertain. Your tech stack is the foundation upon which your digital business stands. Choose wisely, build flexibly, And remember, the best technology decisions are actually business decisions in disguise. Because the right foundation doesn't just support what you're building today, it enables what you might become tomorrow.